Okay, guys, good to talk to you all again. We're going to be talking about problem solving again today. So let's go ahead and look at our lesson objective. Okay, our lesson objective is 3.5B, and that's represent and solve 1 and 2 step multiplication and division problems within 100 using arrays, strip diagrams, and equations. And by the end of the lesson, we want to be able to, the I can statement is I can use models to solve word problems. So got a video right here about how to solve 2-step word problems for multiplication in 3rd grade. Let's go ahead and get ready and watch that.
Welcome to kidsacademy.mobi.
Hello everyone. Let's open the worksheet. Don't forget to like this video and subscribe to our channel. You can find the link to this app in comments below. All right, so we have a really fun worksheet. The name of our worksheet is called Multiplication and Division, 2-step word problems. You remember, a word problem is kind of a story, and you're going to read through the story and figure out what to do with the numbers. And today we've got multiplication and division. Those are kind of hard, but you guys are going to be able to do this today. I know you can. The first thing says, solve these 2-step word problems and check the correct answer. So we have to read through the word problem here, and we're going to come down here and we're going to put a check next to the correct answer. Let's read through this. It says, Serena and her siblings eat 2 packets of crackers a day. Each packet has 10 crackers. How many crackers do Serena and her siblings eat in 3 days? So let's start first with the first sentence. Serena and her siblings eat 2 packets of crackers a day. What I like to do is, as I hear something, I like to draw out a picture to help me to kind of understand and organize what it is that I'm reading. So it says that they eat 2 packets of crackers. So we'll pretend that this is a packet of crackers and there's 2 of them, and they eat that in a day. So this is for 1 day. Okay, and I'm going to write this out to the side. Then it says each packet has 10 crackers in them. So inside of these, there's going to be 10 crackers total. Okay. How many crackers do Serena and her siblings eat in 3 days? Well, I know in 1 day, this is how much she eats. So let's do this. This is for day 1. Then we've got day 2. She eats, once again, she eats 2 packets of crackers, and inside each one, there is 10 crackers. And then it says for 3 days, so we need one more, 3 days. Okay? And again, I'm going to draw out the crackers. So here I'm going to draw out the crackers, and I've got 10 here and 10 here. So it wants to know how much did they eat in 3 days. So we're going to add this all together. And since it's all tens, I'm going to count by tens. So 10, 20, 30, 40, 50, 60. So in 3 days, all of her siblings ate 60 crackers. Oh my goodness. So let's come over here. Do we see it? There it is. There's 60 crackers. So I'm going to put a check right there next to that one. That is the correct answer. Let's go down to the next one. Great job on that first one. This one says, Serena makes dresses for her dolls. She makes 3 dresses a day. She adds 2 buttons onto each dress she makes. How many buttons will she add in 4 days? So let's do this. Let's figure out, Serena makes dresses for her dolls. She makes 3 dresses a day. So let's come over here and let's draw out 3 dresses. So here's 1, 2, and 3. Okay? And she makes that in 1 day. So I'm going to write that out to the side. For 1 day, she makes 3 dresses. She adds 2 buttons onto each dress she makes. So each one of these dresses is going to have 2 buttons. Okay? How many buttons will she add in 4 days? So if this is for 1 day, how many buttons does she make? She makes 1, 2, 3, 4, 5, 6. So in 1 day, she makes 6 buttons. Okay, so there's 6 buttons that she makes. How many will she make in 4 days? So I want to take 6 and I want to multiply it by 4. So I'm going to take that and I'm going to take 6 times 4, and we should know the answer. The answer is 24. If you didn't know the answer though, you could come over and you could draw out a picture that for each day, she has 1 day, she has 6 buttons. So, but we want to times it by 4. So we're going to write 6, 6, 6, and 6. Okay, so this represents 6 times 4, and we could count by 6s to figure that out, okay? But the answer is going to be 24. So I'm going to come over here, and I'm going to put a check next to 24. That was really hard, multiplication and division, but you guys did a great job. Thank you. Bye-bye.
Like us and subscribe to our channel. Find links to our apps and comments below.
Okay, let's go ahead and look at this problem real quick. It says, in August, Jace caught 5 fish each Saturday for 4 weeks. In September, he caught twice as many fish as he caught in August. How many fish did Jace catch in September? Okay, so first thing I'm going to do is I'm going to use my cube strategy. I'm going to pick out all the important information. What I'll do is I'll circle all the important information. Okay, and it sounds like I'm going to circle the numbers and labels basically. So 5 fish, and that's over a period of 4 weeks. I'm also going to circle twice as many fish right here. That's also going to be one of my operational clues. Next thing I'm going to do is I'm going to underline the question. And the question is, right here, this question mark, how many fish did Jace catch in September? So if I don't answer how many fish he caught in September, I'm not done with the problem. So I need to make sure I get all the way to the point where I figure out how many fish he caught in September. Next thing I'm going to do is I'm going to box in my operational clues. So right here, each. Okay, that's basically talking about, usually whenever I see the word each, that's going to be talking about equal size groups. I also got twice as many. Twice as many means 2 times as many. And that's most of my operational clues. So the next thing I'm going to do is I'm going to start evaluating. I'm going to use my little addition, subtraction, multiplication, division little cross right there to help me kind of decide on what operation I'm going to use. I'm going to kind of focus right here on this first part, and what I'm trying to find out is how many fish he caught in September, but I think in order to figure out how many fish he caught in September, the first thing is I need to figure out how many fish he caught in August. So I'm going to look at this part of my question right here. First sentence. It says, in August, Jace caught 5 fish each Saturday for 4 weeks. So I have 5 fish and 4 weeks. So typically when I have different labels, most of the time it doesn't make sense to add those together. So fish and weeks, fish is a fish, and weeks is a measurement of time. So basically I'm not going to add or subtract that type of thing together. So if it's not addition, subtraction, that means I'm probably going to use multiplication or division to solve this problem. And also 5. So I'm trying to figure out how many fish he caught in August. So I think probably I see 5 fish each Saturday for 4 weeks. Okay, it sounds like I'm going to have more than 5 fish in the period of August because he did 5 each Saturday for 4 weeks. So if the operations make things bigger is addition and multiplication. So if I circle addition and multiplication, I look at that, I end up circling multiplication twice. I'm also going to use my get strategy. I'm going to use another strategy, so just another strategy to help us understand maybe what operation to use. So, and whenever I'm talking about equal size groups, I like to use a get strategy. That helps things make sense to me. So I have 5 fish each Saturday for 4 weeks. Okay, the first thing, the groups. Okay, I have 4 weeks and I have 5 fish. So I don't think either one of those are my total. So my groups are probably going to be the weeks because I really can't put weeks into fish. So I think my group's going to be my 4 weeks. Abbreviate that with a W. And right here it says 5 fish each Saturday. So my each is going to be my 5, and that's going to be my fish. So what I'm trying to find out is the total. This is going to be the total amount for August. This is the total amount of fish he caught in August. So I think whenever I'm using the get strategy, I'm trying to find out the total. That sounds like a multiplication problem. So a multiplication is groups of how many groups are in each, or how many groups there are and how many are in each group. So it sounds like the multiplication problem I'm going to solve is 4 times 5. So I'm going to go ahead and use an array. I know that's a pretty simple multiplication problem. I'm still going to use an array because I like models. So I'm going to model that right here. And my groups are my weeks, so that's 1, 2, 3, 4. So I got my 4 weeks right there. And then there's 5 in each. So that's already got 1, 2, 3, 4, 5. So I go ahead and fill in the rest of my array. Make sure I have 5 in each row. It looks like I'm catching goldfish, isn't it? So I've got 4 rows with 5 in each row. So I go ahead and that would be 5, 10, 15, 20. So it looks like in August he caught 20 fish. So that means that my total right there is 20, and that's 20 fish in August. Okay, but that does not answer my question of how many fish he caught in September, does it? So I think I'm going to have to look at the information right there, and it says he caught twice as many fish in August. So I'm going to look at that real quick. So I got my groups right here, got my each, and I got my total. So we're going to use this to evaluate right now, and it says he caught twice as many fish in August. So I think that's going to be my groups. I'm going to have 2 groups. I'll make 2 groups right here. And in each group is going to be 20, because that's going to represent the August fish right there. So I'm still trying to find out the total right there. So the total is going to be the fish that he caught in September, because he caught twice as many fish in September than he caught in August. I'm going to make a strip diagram to solve that. So I got a strip right here, and I'm going to kind of make a part whole strip right here. So the top right here is going to be fish that he caught in September, and I got 2 groups. I'm going to make 2 groups right here, and in one group I'm going to have this 20, and I'll have 20 in this group. It's going to represent twice as many fish. So if I want to figure out how many over the total right there, I can, whenever I got the get strategy and I got 2 groups with 20 in each group, that sounds like 2 times 20. So figure out what 2 times 20 is. I can go ahead and use a strategy that we did before, because we typically don't talk about our 20s. And we could skip count by 2 up by 20, but I don't have 20 fingers. I can take my shoes off, but there's an easier way of doing it. I could go ahead and just go 2 times 2 is 4. And since I'm doing, instead of doing, I'm not doing 2 times 2, I'm doing 2 times 20, I put a 0 behind it. Or I could also say doubling 20 is 40. But it looks like he caught 20 fish in August, and if I double that, that would make 40 fish that he caught in September. So does that answer my question? How many fish did he catch in September? Yes, he caught 40 fish in September. Okay, let's go and look at this problem. It says Emma organized her collection of colored beads to make necklaces for 6 of her friends. She had 4 different colors of beads, with 15 of each color. Emma used all of her beads to make the necklace for her friends. How many beads did Emma put on each necklace? So we'll go ahead, we'll use a cube strategy to go ahead and try to figure out what information is important in this. So I'm going to circle the important information. So it looks like she's got 6 friends. That's important. I have 4 different colors of beads. and 15 colors of beads. And it also says, this looks important to me, she used all of her beads to make the necklace. Okay. So that looks like all the important information I need. So next thing I'm going to do is I'm going to underline the question. It says, how many beads did Emma put on each of the necklaces? She used all the beads, and we're going to figure out how many beads did she put on each of her friends' necklaces. Next thing I'll do is I'll box in some information. Right there in my question, I see each. We'll try to figure out how many beads did she put on each necklace. I also see right here each color. That's 15 of each color. So those are some pretty good operational clues. Now we'll do some evaluating. Okay, I'm going to evaluate this question. I think there's going to be, I got a lot of stuff circled here, so I think I'm going to have at least a couple steps I need to do to solve the question. So I believe the first thing I need to do to solve this question is I need to go ahead and figure out how many beads she has. So I already bought, and that's up here, that's in this part of the question, says she has 4 different colors of beads with 15 of each color. I think we can figure out from that how many beads she has. So I'm going to go ahead and use a get strategy because I already said each is talking about equal groups. So figure out how many groups there are, how many are in each group, and what the total is. So right here, right off the bat, there's 15 of each color. So the 15 is going to be how many are in each group. And that's beads. Okay, groups. I got 4 different colors of beads. So 4 different colors, but this is talking about colors of the beads. So 4 different colors is going to be my groups, and this is colors. So what I'm trying to find out is how many total beads she has. So that's what I'm trying to find out. So whenever I'm talking about equal groups, and I'm trying to find out the total, that's going to be a multiplication problem. That'd be 4 groups with 15 in each group. It's 4 times 15. And what I'm trying to find out is 4 times 15. If you look over here on the left, I'm going to use that strip diagram to solve it. So I'm going to use the strip diagram right there to solve the first part of the problem. And we're also going to use a standard algorithm for a 2-digit by 1-digit multiplication problem just to double check our work. So, and I'm going to do something a little bit different. I'm going to use Roman numerals down here in the bottom because it makes it a little bit easier to count. Because I'm not really good at counting by 15s, but I'm pretty good at counting by 10s. And this is a Roman numeral for 10 and X. So that's 10. Okay. And then the Roman numeral for 5. So 10 and 5 is 15 is V. So I can go through here now and count. So that's 10, 20, 30, 40, 45, 50, 55, 60. So that means she has 60 total beads. So I need to go and do the next part of the problem now. Well, first let's go and use a standard algorithm. I forgot we're going to use a standard algorithm. So 15 times 4. So when we're doing a standard algorithm for 2-digit by 1-digit multiplication, we multiply up first, and 4 times 5 is 20. I'm going to carry my 2 and put my 0 in the ones place. The next part is the ones place by the tens place, and that's 4 times 1 is 4, plus 2 more is 6. So it looks like 60 the same way we did by doing the strip diagram. And we said that's our standard algorithm for doing 2-digit by 1-digit multiplication problem. So we know we have 60 beads now. So I got another strip diagram down here on the bottom, and let's go ahead and analyze the rest of the problem. So the rest of the problem is talking about she's got 6 friends. And Emma used all the beads to make necklaces for friends. So I'll go ahead and what we're trying to find out is how many beads did Emma put on each necklace. So that's talking about equal groups again. So I'll do my get strategy for the second part, G, E, T. And we already said that she used all of her beads, and all of her beads is 60. So that's going to be the total. The total is 60 beads. Abbreviate with B. And right here in the question it says, how many beads did Emma put in each necklace? That's going to be what we're trying to find out. That's in the question. So it looks like the each is what we're trying to find out. And the groups are going to be her six friends. So our groups are going to be our 6 friends. So when I'm using the get strategy, and I know what the total is, that sounds like it's going to be a division problem. And the division problem is 60 divided by 6. I forgot to put my 60 up here was my answer to 4 times 15. So I need to go ahead and figure out what 60 divided by 6 is. Okay, I could go ahead and say, we use an equation, we could say there's 6 groups times how many in each group equals 60. If we know our multiplication factor really well, we might know that. Okay, or we can, I use this strip diagram down here, and down here on the bottom, well first the total right there would be go in this part, so that's going to be my 60 total beads. And my strips down here are going to represent her friends, her 6 friends. So let me think about this for a minute. Can I go ahead and, is there a quicker way of separating out the beads to where I didn't have to draw a bead for each one? Or could I just go ahead and put a bead in each one? We could do that. We'll go ahead and do that. We'll go ahead and say that so we're going to start separating out the beads. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, and 60. So those are the necklaces right here. It looks like I got 2 rows of 5, and 2 rows of 5 represents 10. Or I could have just said an easier way to do it is go ahead and say, well, we got 6 groups there, and I'm pretty sure if I put 10 in each group, I could do my little X for my 10. So we go 10, 20, 30, 40, 50, 60. So now you can see there's 10 in each group. So I know that 6 times 10 equals 60, or 60 divided by 6 equals 10. So that means each of our friends will get 10 beads each on each necklace. Each necklace. So there would be 10 on each necklace. And right here was our 60. Okay, we're going to look at a guided practice problem here. It says, Katrina arranged 12 dominoes into 3 rows of 4. Okay, which of the following does not show another way Katrina could arrange the dominoes? So, important information in this problem, that there's 12 dominoes. That's probably the most important thing. We can also talk about there's 3 rows of 4. Okay, that could be important. We'll use that later on. I'd underline the question. It says, which of the following does not show another way Katrina could arrange the dominoes? I'd probably go ahead and box in the word not. That's important. And I'd say rows, okay, of 4. Okay, so that's signifying that they're doing arrays. So since they're making arrays, it's going to be a multiplication problem. So we're going to go ahead and solve this. And how we're going to solve it is we're going to look at our answer choices, and we're going to solve the answer choices. So answer choice A right here. It says 4 rows of 3. So basically, we're going to actually solve all the answer choices and figure out which one does not give us 12 dominoes. So answer choice A, 4 rows of 3. How many dominoes is that? Yep, that's correct. I know there's a community property of multiplication. So if I switch it around, I had 3 rows of 4 up here. So if I took and made 4 rows of 3, I'd still get 12. Answer choice B, 6 rows of 2. How much is 6 rows of 2? Yep, that's correct. If I double 6, that would be the same thing as 6 rows of 2. And if I double 6, I get 12. Answer choice C, 1 row of 12. How much is 1 row of 12? Yes, that's a pretty easy multiplication problem. That's 1 times 12. And we know 1 times 12 is 12. So answer choice D, how much is 8 rows of 4? Okay, well, let's look at that. 4, if I'm multiplying something by 4, I've got 8 rows of 4. I could just go ahead and double 8. If I double 8, that's 16. If I double 16, I get 32. So 8 rows of 4 would be 32 dominoes. Oh, not 33, but 32. 32 dominoes. So that looks like the one that is not another way I can arrange the dominoes. Okay, on this problem right here, it says Kellen and Hunter both received new puppies. Each boy bought packages of dog treats for the puppies. The strip diagram shows the packages of dog treats. How many total dog treats did the boys buy? So this problem, all the information we really need to solve the problem is down here in our strip diagram. And I will go ahead and underline the question just to make sure I understand what it's asking. It says, how many total dog treats did the boys buy? So I pretty much need to figure out how many treats are here all together. So in strip diagram right there, I see I got equal size groups. And what math problem would I use to solve how many math treats or how many dog treats Kellen got for his dog? Yes, I got 4 groups right there of 8. So that'd be 4 groups of 8. What is 4 times 8? Yeah, I know if I double 8, I get 16. If I double 16, I'll get 32. So that means he got 32 dog treats. Dog treats. Okay. Hunter, what math problem would I use to figure out how many dog treats Hunter got his dog? Yep, that's correct. I've got 3 groups with 10 in each group. What is 3 times 10? That's correct. That's 10, 20, 30. So 3 groups of 10 is 30. So that means he got his dog 30 dog treats. So what am I going to do to figure out how many dog treats they have total? Yes, that's correct. I'm going to use addition. I'm going to do 32 plus 30. What is 32 plus 30? Yep, that's correct. It is 62. So they got 62 total dog treats. Okay, it's time to go ahead and complete your independent practice again. Just like always, there's going to be a blue puzzle piece down below this video. And I'll go ahead and put a PDF there if you'd like to go and print it out and work out the problems on pencil and paper. Typically, third graders do better if they use pencil and paper, use your strategies. So I'd recommend you doing that if you have the ability of doing that. But take your time and just do your very best. And if you have any questions, please email your teacher or send them a message on Schoology if something's not working the way you think it should be, or you don't understand a concept or anything for any reason at all. Just send your teachers a message and they'll be able to help you out. And just as always, take your time and do your very best, and best of luck to you.